So we're going to look at lesson 1-7 notes today. Remind me at the end of the period. And if you want the review worksheet to take home with you over the weekend, you can take it with you. Lesson 1-7 is the last lesson in the chapter. We are looking at chapter test next Thursday. I can't do Friday because you guys would not get a whole period because 1 o'clock is in the middle of this class. So, and then some.
Is that when the drill is?
Oh.
Yeah. Like that's when
I forgot we were doing that. I was like, why? It doesn't matter. If it's
Yeah.
1 o'clock during this period.
So, with that in mind, if we'll be working on review next week, if you want to go ahead and take the review worksheet so you can start looking at it. It's a lengthy review worksheet because there's a lot of stuff in this chapter. And so if you want to start working on it, working on individual pieces, you can take it. But in the meantime, let's talk about lesson 1-7. Lesson 1-7 is modeling with functions. So to take a function and work with it like coming from formulas. Okay? Several different types of problems you're going to see today. Hopefully I'll get through all of them in your class. There was one short this morning. So on some of these, there is a little bit of prior knowledge you have to know. Okay, so some of these formulas, I'm hoping that you guys know them. First example, write the area A of a circle as a function of its, and then the first time we're going to do radius R, the second time diameter D, and the last time circumference C. So first of all, what is going to be helpful to know to do this problem? Area of a circle. What is the area of a circle? Good. And you guys don't want to hear it, some of you, but you're missing your air 5. Okay, a real 5.
You checked my homework and I went for a fist bump.
I missed it?
Yeah,
sorry, I didn't mean to leave you hanging. So, okay. So A equals pi r squared. I would like to think by pre-cal level we know that. Okay. Now, it's not that hard to memorize. Okay, so A. Write the area of a circle as a function of its radius r. As a function of its radius r means that r is the variable within the formula. So what is the area of a formula in terms of r? What is the area of the circle in terms of r? Didn't we just say it? What was it? Pi r squared. In other words, in this case, there's nothing to do for part A because the area of a circle formula is already in terms of r. There's nothing to adjust.
Except for the y.
Okay. Now, B. So B wants us to use the same idea, area of a circle, but this time we want area of a circle written as a function of its diameter. So that means I still want area of a circle, but I want to use diameter in there instead of radius. In order to do this, what you have to consider is what is the connection between radius and diameter. Okay? She phrased it as radius is half of diameter. So could I say 1/2 d or d divided by 2? The other way to think about this, I don't know did anyone start off thinking the diameter is 2 times the radius?
Yeah, see, that's one.
Okay, well, both will get you to where I need you to be. Okay, if you start off thinking, okay, diameter is 2 times radius, or if you said diameter is half the radius, they both say the same thing. I'm trying to write my area formula now.
Would it be 2r equals d or 2d equals r?
That'd be 2r.
2r equals
I thought
d.
you just said the diameter times 2 equals radius. Okay.
I might have said it backwards. It is always, I'm not going to
Yeah.
state I didn't because I never know. My goal here now is to write the area, but when I do my pi r squared, I don't want to use r. I want to use d. And so that means we have to think about the relation. So area of a circle is pi times the radius squared. What's another way to say radius?
B over 2.
half of diameter, right? Radius was half the diameter, or in other words, d over 2. Since it was r squared, we're going to say d over 2 quantity squared. So we've just changed our area formula from having r, it being a function of r, to now it's a function of d. Can you do a little cleanup there? What happens when you take d over 2 and you square it?
D squared over 4.
Okay. So pi times d squared over 4. There's not just one right way to write this answer. But if I think about my variable piece separate, and then I take my numbers out front, there's a pi on top, a 4 in the denominator, and so I'm going to have pi over 4 times d squared. As I said, I'm not saying that would be the only way you could express your answer, but that is one way to express your answer.
So if you just have pi times d squared over 4 with that.
That's equivalent. Okay. You could also just put it together and say pi d squared all over 4. Okay. But the idea is looking for the connection between r and d and then changing. Part C, same idea, except this time we're changing to circumference. So you have to have a little bit of prior knowledge about circumference. It feels like no. Huh?
The 2 pi r.
Mm-hmm. And technically there's another one also. 2 pi r is what I'm going to use because my original area formula was in terms of r.
It's something with d.
Okay, pi d or 2 pi r are the circumference formulas. You don't necessarily have to know both. They're equivalent, right? Because in the first one it's d. We know d is 2r, so in the second one it's 2r. So in my area formula, I have an r, yes? I want to substitute in for r a value that involves c. So c equals 2 pi r. Can you solve that for r for me? How do we solve that for r? And how do I get r by itself? If it's 2 pi times r, divide by 2 pi. We divide one side by 2 pi, divide the other side by 2 pi, yes? And so now, if I flip that, I know r is c divided by 2 pi. So you know what I'm going to do? Let's rewrite our area formula. Area is pi times r squared. So what am I going to say? Pi times pi times c over 2 pi quantity squared. Okay, so now we're writing area in terms of circumference, where circumference is the variable we have in there. Clean it up a little bit. Still pi times, what's c over 2 pi quantity squared?
C squared over 4 pi squared.
C squared over 4 pi squared. Because you do have to, pi squared is pi squared. You also have to square the 2, and 2 squared is 4. Okay. If we multiply these together, pi as a fraction is pi over 1. What can I do here? Yeah, can we cancel pi? It's kind of like working with a variable. I know it's not a variable, but 1 pi on top cancels with one of the pi's on bottom. And so now, if I put that all together, on top we have c squared, on bottom 4 pi.
crazy how all these letters and numbers and things actually get you an answer.
Looks a little crazy, huh? Okay. Questions on that one?
So we basically just be plugging in numbers for these.
What do you mean?
And we're going to be plugging in numbers for C and A and stuff.
You could if they asked you to. I don't necessarily know. Right now, it's just more about working with the formulas today. Okay, let's look at example 2. Start by reading, of course, right? A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open-top box. Write the volume of the box as a function of x. So I want to start by drawing a picture. What do I need to draw here? Not a square. I'm going to draw my rectangular 18 by 15-inch piece of cardboard. Okay, so there's my rectangular piece of cardboard. I know it is 8 inches by 15 inches long. And then what's done to this 8-inch by 15-inch piece of cardboard? Okay. A square of side x inches is cut out. So that means we take this corner right here, we cut a square out. That square that we cut out is x by x. Or in other words, each of the 4 sides is x in length. And we do this at each of the 4 corners, right? So up here, I cut a square out that is x by x. Down here, I'm cutting a square out that it's x by x, and down here, cutting a square out that is x by x. So, think about here. We started with this 18 by 15-inch piece of cardboard. Now we're cutting these corners out, right? And it says they're going to, the sides are folded up to form an open top box. So what do I mean the sides are folded up? If you cut a square out, and you cut a square out, what's going to fold up? This piece in the middle is folding up, yes? If you cut these squares out, this piece is folding up, right? So now, what we need to figure out...
What's the distance of the piece in the middle?
Yeah. How long is that flap that we're folding up? So I'm working on the top flap right now. How long is that flap that we're going to have to fold up?
15 minus 2x.
How long was it originally?
15.
From here to here it was 15, yes? You cut out that square. How much are you taking away? An x here. You cut out this square, you're taking away an x here. So what are you taking away from that 15? 2x. So the length of my box is now 15 minus 2x. What about my side?
8 minus 2x.
Yeah, it was 8 long. You cut out x from one corner, x from another corner. It's now 8 minus 2x. Okay. I think I forgot to go back and ask, what is this question asking? The volume of the box as a function of x. So that means we're going to do volume, but we can only have x's in our volume. Now, okay guys, prior knowledge. How do we do volume of this open top box? How do we do volume? Okay. Volume of a rectangular prism. Length times width times height. Sound familiar? We'll get there. So, we're writing a function for, or a formula for volume, so we're allowed to start with V equals. What is the length of my box? Okay. Cardboard was 15. We take away those two x's, so the length of the box is 15 minus 2x. What is the width of the box?
80 minus 2x.
Okay. Are we okay with that? Now, the last question is what is the height of this box? And we do know it. It's there. Think about it. What's happening? It was 8 by 15. We are folding these flaps up. What do you know when you fold that flap up? It's laying down. When that flap folds up, it is now the height. How tall are those flaps? They are x. So my height is x. Did we write a volume function in terms of x? Yeah. It is volume in terms of x. I'm going to be nice. You don't have to multiply it out. If we wanted to multiply it out, we'd be foiling and then multiplying by x. I think I'll pass. Okay? Questions on that one? Okay, let's look at example 3. Mark received an 8.5% salary increase. His salary after the raise was $36,890. What was his salary before the raise? You're going to end up with a calculator to do this problem, I agree. So, we know the after, yes? We know that afterwards, his total salary is now $36,890. Do we know what his salary was before the raise? No. So what can we use for his salary before the raise? X. And so I'm going to use X for my salary before the raise. Now, you have your salary before the raise, and then what do you have to have? Plus your raise. So your salary, your original salary, plus your raise has to equal $36,890. If your salary was X, how do you find your raise? If it says I'm getting an 8.5% salary increase. We're not going to divide by 8.5. If we're trying to find what our like how much they're going to add on to my salary, if I want to find how much they're going to add on to my salary, I'm going to take this 8.5% and multiply it by. We are, but I'm setting up an equation to do that. Is what I'm saying. Okay, and we're still not just going to divide by that. That's where I'm trying to lead you. Okay, the common mistake is to say, oh, well, to find my salary before the raise, I'm just going to divide that 36 number by my 8.5%, and that won't get you there. That's where I'm trying to, okay? So if my original salary was X, I'm adding some. That amount I'm adding is whatever 8.5% of my original salary was, so 8.5% of X. Now, how do we use percents in an equation format? Yeah, divide by 100, move the decimal 2 left. And so to X, I'm going to add, 0.085 X. So look and see if this makes sense. We'll clean it up.
That's a 0.085.
X is my original salary. That's what I started, yes? And then I'm going to add my raise. How do I find my raise? Well, I do 8.5% times the original salary. What's the original salary? That's what we're calling X. So 0.085 times X. Altogether, that has to equal $36,890. Now, how do we clean up that left side? No. Clean up the left. What kind of x is this? 1x. What's 1x plus 0.085x? 1.085x equals 36,890. This right here, when you're asked to write an equation, you could write this original equation, or if you see what's happening, you could write just this equation. But the idea is your new salary is 108.5% of your previous salary, right? And so that's why I said original plus the 8.5%. So if I get a 2% raise, I'm now earning 102% of what I'd earned previously. And that's what this represents. So now, how do I solve here? Divide by the 1.085. What is 36,890 divided by 1.085? 34,000. So 34,000 was my amount before salary. Or before my raise, sorry. That's a nice raise. I want an 8.5% raise. An extra almost $3,000 there. Did you see what we did with that? Yes, no? Okay, because it's a fairly simple problem to do if you can remember what to do and how to do it. Okay. Real quick before we move to the back side. What is the cost of an item after a 45% decrease?
0 times what the first price was by 0.45.
Okay.
And then you subtract that from the original.
Okay.
I do that all the time in school.
Okay. And here we're going to talk about a shortcut then. Okay. But so what is the cost of an item after a 45% decrease? You're going to start with the original cost. What's my original cost? In this case, I'm going to call it X. And since it's a decrease, I'm going to subtract off 45%. How do I know what 45% of that cost is? It's 0.45X. Okay. Well, what is X minus 0.45X? Basically, what is 100% minus 45%? 55%, right? So the idea of 1x minus 0.45x is 0.55x. Or in other words, the idea here is, and going off what you said, Isabel.
Figure out how you would do that. Because that's all you could do, add the 1 and then you already get it.
Yeah.
And you don't have to
So if I see something, and I'll use a round number instead, if I see something in the store that is 40% off, rather than doing 40% of something and then having to turn around and subtract it, if I know something is 40% off, I could just say what is 60% of the original cost. So doing 0.6 of something instead of 0.4 and then subtracting it.
instead.
Yeah, that's the shortcut there. There is your real, immediate real life option. Yeah.
I love doing that. I mean, by now I can do most of it in my head, but it's helpful.
And you know, we get reliant on like the signs at Kohl's or whatever that say, okay, 30% off. If it's this originally, now it's this. This originally, now it's this. But then what happens when they don't have your price on there? Okay. I mean, you can kind of ballpark it. You do. You do. But that's kind of the shortcut. If it's 45% off, realize you're paying 55% of the original cost. So there is an advantage, you know, to having a little bit of math nerdiness in me.
My grandma told me to do that.
Okay, let's see if we can get through both of these. I'd like to. A square is inscribed in a circle. What is that visualized? A square is inscribed in a circle. What is that?
A square inside a circle.
Okay, a square inside a circle. When we draw this square inside the circle, what has to be true of the 4 points of the square? They're touching the circle, right? I forget. Do I want to draw my circle or draw my square first?
I'm drawing my circle first.
I don't know. Either way.
I drew my circle first, and mine came out successful.
Have you seen the video of the math teacher drawing a perfect circle?
Yeah.
Okay. I drew my circle first. I think my square looks a little more rectangular-ish, but you get the idea, right?
The other square's a rectangle.
Okay. Now, we want to know what is the area of the square, sounds easy enough, as a function of the radius of the circle.
See, that's what you do. I see that part.
Okay. So first of all, let's talk about what is the area of a square.
Length times width.
Length times width? Or here's what I'm going to say. Common math notation is the side of a square we call S. And so if the side of a square is S, that means all four sides are the same, right? So what's the area of the square then?
4S.
Now if you're doing area,
S times S.
S times S, which is S squared.
I was thinking.
So there is formula for area of a square. Yes? What's the problem? I don't have it in terms of R. I have it in terms of S. Okay. What does R mean in this picture? The radius. Where is the radius? It's a line that goes from the middle of the circle to an edge. Where would it be beneficial for me to draw the radius? Going to one of the points of the square. So there is R. Here is another R. What kind of triangle do those two R's in that S form?
A three-sided one. Nice sauce.
Well, technically, if I'm going to have,
It's supposed to be an equilateral.
well, not necessarily equilateral, but if you're going to have four of these triangles around the middle, this angle is going to be a right angle. It would not be equilateral, but it'd be a right triangle.
I just saw my sauce.
Sorry. I know, you have to allow for error there. Okay. What's the relationship, if this is a right triangle between R, and S? Two sides and a hypotenuse? What formula pulls that together? Good. A squared plus B squared equals C squared is our Pythagorean theorem, right?
Are we going to be given all of these formulas?
R squared plus R squared equals.
So A squared plus B squared equals C squared can turn into R squared plus R squared equals S squared. Now, what do I need? I need something solved for S here, right? First of all, what is R squared plus R squared? 1R squared plus 1R squared. 2R squared. Officially, how do I solve for S? If it's S squared, we're going to take the square root. Excuse me. Square root of S squared is S. What's the square root of 2R squared? Okay. What's the square root of 2? Square root of 2. What's the square root of R squared?
So it's R times square
They're
root of
multiplying, not adding.
2. R times square root of 2.
I did not.
If this had been the square root of R squared plus 2, it would be a no-go. Okay? That's the difference. Now, what am I wanting you guys to do with this S? Plug it in. So now my formula becomes A equals, what am I putting in place of S? R square root of 2, quantity squared. Clean it up and we're done. What is r when we square it? R squared. What is square root of 2 squared? 2. So this is 2r squared. Okay, I went an extra step there. I should have skipped. Oh well. Did anyone catch right here s squared was 2r squared? Had I been thinking, we could have just subbed that in right there. Sorry. Shoulda, woulda, coulda. It worked out the same both ways. Okay. That'll be something we'll have to work on, guys. That's a skill there, right? We have to work on that. Let's look at example 5. It's quick. A number added to 4 times that number is 450. What are the two numbers? Okay, we're going to write an equation. A number. I don't know what number I want. A, X, N, whatever, right? I'm going to use N for number. Added to. What's added to mean? Plus. 4 times that number. 4n. You guys are catching on. Is. What is in the math world? Equals 450. Did we just write an equation for that scenario?
Yeah.
A number n plus 4 times that number n equals 450. Can you clean up?
5n equals 50.
1n plus 4n is 5n. 5n equals 450. Divide by 5, and n is 90. What did the question ask me? What are the two numbers? How many numbers do I have? 1. I know n is 90. How do I find the other number?
What's the other number?
The other number was 4 times that number. So what is 4 times this number? What is 4 times 90? 360. Because they wanted to know what the n and the 4n were. Okay. It's a lovely little homework blank for you. Page 148, 1 through 16, 18, 19, 21 to 23. And I'll hand out here momentarily. Don't forget to grab a worksheet before you leave if you want.